In this video, we're going to look at section 1.2, which is on formulas and applications. Specifically, what you're going to be asked to do is, given a formula that's already solved for one particular variable, you're going to be asked to rearrange it and solve it for a different variable. To solve a formula for a variable, you will isolate that particular variable on one side of the equation, much like we were doing in section 1.1 when we were solving equations for x. We were isolating x on one side of the equation. We're going to try to accomplish the same thing here. What's more difficult about these problems is that there are other variables that are going to get in your way that you don't really care about, but you still have to deal with them because you can't make them go away. So you're going to be stuck with these other variables that you want to get to the other side of the equation and isolating the variable that you're trying to solve for. My advice is to treat all the other variables that you are not solving for as if they were just numbers. Don't treat them special. I think the difficulty a lot of students have with these problems is they want to treat all the variables equally and treat them all in a special way. And you can't do that. You have to pick the variable that you're trying to solve for as your special variable and treat that one special, isolate that one, treat all the other letters as if they were just numbers. Get them out of the way the same way you would get numbers out of the way if they were in the same place. All right, so let's take a look at some examples. So we're going to start off kind of easy here. We have this formula. Now, really, in my opinion, formulas should be equations that have some particular purpose or meaning behind them, and this section is not holding to that. So they're going to give us these formulas, I'm doing air quotes for that, these formulas that really don't mean anything. They're just kind of random letters kind of put together in a random mathematical way. So we have this formula here, which is A equals J times Q. That formula is currently solved for A. However, we're being asked to rearrange the formula so that it's solved for Q instead. Right, so the directions here tell me solve this for Q. Right, so it says right here. And so we want to get Q by itself. We want to isolate Q. Now we have, with the Q, we have this other variable J. And again, if we try to treat these variables as both special and meaningful, and we have to be careful with them, we're going to have trouble figuring out what to do. But we're not going to think of it that way. Q is our special variable. That's the one that we really want to focus on and treat as a special thing. J is just some other random letter, and I'm going to treat it just like I would treat a number. It's really doesn't mean anything to me. I'm going to treat J the same way I would treat 5, right? If I had 5Q, what would I do to get Q by itself? I would divide by the 5, right? Whatever number's in front of it, I'm dividing by that number to get rid of it, because this is multiplication. To cancel out a multiplication, we will use division. If there was a 5 here, I would divide by 5 to cancel it out. So I'm going to do the same thing with J. Having a J here, I'm going to cancel that out, since it's being multiplied by J, by dividing J on both sides. So I'll divide J on the on the right-hand side, and I'll divide J on the left-hand side. On the right-hand side, the J's cancel out. We have a Q left over. Therefore, we've isolated Q. On the left-hand side, I keep getting my directions backwards. I apologize for that. On the left-hand side, we'll have A over J. And so we just leave it the way it is. So again, we treat these extra variables as if they're just numbers, but unfortunately, they don't really simplify or go away like numbers usually would. Right? If these were just numbers and I divided by 5, I'd get like 20 divided by 5, which would simplify to 4. Variables are not going to simplify like that. And so we're going to be stuck with these kind of complicated expressions. But you still treat those variables the same way you would treat numbers that are in the same place. So this would be my answer, right? This is the formula that we were just given. It's now solved for Q because I have Q isolated on one side of the equation. So this is what I would type in to Math Excel. Now, something you need to be very careful about, and this is not a Math Excel issue, it is a math issue, which is variables are case sensitive. Just like your password is case sensitive. That means a capital letter is treated differently than a lowercase letter. Right? So if your password is love, L-O-V-E, all lowercase, but you type in capital L-O-V-E as your password, it's not going to be correct because the case of the letter makes a difference in whether the password is considered correct or not. Math variables work the same way. A capital A is a different variable than a lowercase a. It's also true in computer programming. So if you ever did a little bit of computer programming, you'd learn a capital variable A is different than a lowercase variable a. The computer program would treat those as two different variables, even though they're being represented with the same letter. So when you're typing this answer into Math Excel, you have to type it in as capital Q equals capital A divided by capital J. If you use lowercase a or if you use lowercase j, Math Excel is going to count that wrong because it's not the same variable as what was given in the problem. All right, let's move on to this next example here. We want to solve this for G. Here's G right here. So I want to get G by itself. So what would I have to get rid of first here? If I'm trying to isolate G, yes, I have this other variable over here, this W, but I'm going to treat that just like I would treat a number. And if these were just all numbers here, the first thing I would do is get rid of this number here by subtracting it to the other side. Right? We're adding by 4W, so I'm going to cancel that out by subtracting 4W from the right-hand side. That's going to cancel out that term there. That's what I would do if I only had numbers. I'm going to do the same thing with these variables. So I'll subtract 4W from both sides. Now again, the unfortunate thing is these don't combine together. They don't simplify, so we just have to leave them the way it's written. It's going to be P minus 4W. Right? They're not like terms. They don't combine together, so I just have to write them out side by side like that. That's what I get on the left-hand side. On the right-hand side, the 4W's cancel out. We'll have 4G left over. To isolate the G to get G by itself, we will divide by 4 on both sides. Now when I go to divide, the entire right-hand side gets divided by 4, and that makes the 4's cancel out. So we have just G left over. The entire left-hand side gets divided by 4. So because we have those two terms there, that fraction bar has to go underneath the whole thing. So whenever you're multiplying or dividing, it's important that you apply that operation to the entire expression. And because of that, the 4's here do not cancel each other out, because the 4 also divides into the P. It divides into both of these. 4 divides into P and it divides into 4W. So I can't just cancel out with one of those things. It has to divide into both of them. So I would advise just leaving it as one big giant fraction. Math Excel should be okay with that. So we're going to have P minus 4W. Let's try that W again. P minus 4W, the whole thing divided by 4. That's what I would type into Math Excel as my answer. If you wanted to divide, if you wanted those 4's to somehow cancel each other out, here's the way you would have to do it. You would have to take the 4 and divide it into each term of the numerator. So you have to write it as P over 4 minus 4W over 4. Each of those terms has to get divided by 4. Then, when they're separated like this, those 4's can cancel each other out. And your answer would become P over 4 minus W equals G. And that would be an alternative way of writing the same answer. So either of these would be considered correct. So feel free to use whichever structure makes more sense to you. They're lowercase. So when you type the answer and it's lowercase p minus 4 times lowercase w, the whole thing divided by 4. So make sure you're using the right case for those variables. All right, let's take a look at a couple more examples here. This one's pretty similar to the first one that we did, except there's 2 variables here instead of just 1. Right, so we want to isolate x, which means I want to get rid of the n and the z, which are both being multiplied to the x. So to cancel them out, to cancel out a multiplication, we will use division, and there's no need to just do one at a time. They're both being multiplied, so I'll get rid of both of them at the same time by dividing by both of them. So we'll divide by n and by z simultaneously. On the right-hand side, we'll do the same thing to the left-hand side, divide by nz. On the right-hand side, the n's cancel out, the z's cancel out, and we'll have x left over. That's isolating the x. On the left-hand side, we'll have d over nz. And so that's the answer for that one. So pretty similar to that first one, except you divide by both variables at the same time. Excuse me. So this one we want to solve for h. That's what the directions say right there. So what are we going to do first? Let's rewrite this problem. We have g equals h minus u over z. Trying to solve for h. What am I going to get rid of first? I would advise getting rid of the fraction, right? It's going to be hard to do something with that u while it's stuck in this fraction here. And it's going to be hard to get h by itself when it's stuck in this big fraction. So we need to get rid of the fraction. So I can do that because, think of it this way, you're dividing by z here, right? This fraction means we're dividing by z, so to cancel out a division, we will use multiplication. So we'll multiply it by z to cancel out that dividing by z. If I do that to the right-hand side, I got to do the same thing to the left-hand side. Excuse me. And it doesn't matter which order you put this in. Z times g or g times z. When you're multiplying, the order doesn't really matter. So I'm just going to leave it like this. We'll have z times g equals, on the right-hand side, the z's canceled out. So we're left with h minus u. Now we can get h by itself by adding u to the other side. So we'll get z g plus u equals h. Be careful typing that in that you have the variables with the right case. It's lowercase z, capital G, plus lowercase u equals lowercase h. So make sure you use the right case on those. All right, so that's solving for h. This one's a little bit more complicated. This kind of equation, again, it's a formula that we're going to see things of this nature in, I can't remember what chapter it is. It might be chapter 2 when we talk about graphing lines, because this is what a linear equation will look like. And we'll have to actually solve things that look like this. There'll be numbers. Like this one has a lot of letters in it. When we see this again, we'll have some numbers here instead of a bunch of variables. But we're going to have to deal with things that look like this in the future. So I wanted to make sure to do an example of this now. We want to solve this for x. So again, I'm going to treat all the other variables as if they're just numbers. H, y, j, b, they're not special to me. I'm treating them the same way I'm treating numbers. The only one that's special to me is x. That's the one I want to isolate. So if these were all just numbers here, the first thing I would do, the first number I would get rid of is this number here. And this, I'm adding hy, so to cancel that number out, again, putting number in quotes, we will subtract by that, right? So I'm going to subtract hy from both sides of the equation. That cancels it out from the left-hand side. So I'll have bx left over equals, again, these don't combine together or simplify, so I'll just have to write them side by side. J minus hy. And then again, treating these other variables as if they're just numbers. I want to get x by itself. If this were just a number, the way I would get rid of it is by dividing by that number. I'm going to do the same thing with the variable here. I'm going to divide by b on both sides. And again, make sure that fraction bar reaches all the way across the right-hand side of the equation. So we end up with x equals j minus hy all over capital B. And that is what that formula looks like. Okay, now those, while there was some definite variation in those problems, there was some variety there, they were all essentially of the same type, where the variable that you're trying to solve for, there's only one of them in the formula, and you just have to shove everything else to the other side. There are some differences in the details of how that was accomplished, but that's essentially how all those problems worked. That's one type of problem that you're going to be dealing with in this section when you do the homework. And there's one other type that I won't have quite as many on the homework, but they're not that hard to do if you know the trick. So I'm going to show you the trick for doing these other type of problems. Right? And they're ones that look like this. And the main difference here, you might say, I don't really see how this looks any different. The main difference here is that the variable you're trying to solve for, which is c, exists twice in this formula instead of just once. So let me show you the common mistake that students will make with this problem, right? They'll say, okay, q equals c minus cst. I want to solve for c, so this is what doesn't work, but I want to show you the thing that doesn't work first because it's a very common thing students will do. Let's say, well, if I want to get this c by itself, I'll just add this cst to the other side. And so the answer I'll get on the test oftentimes for this problem is this. Right? And this looks good if you look at just the one side of the equation. If you look at this thing, you're like, oh, that's solved for c. c equals this thing, right? c equals blank. But this is not solved for c because c is not isolated to one side of the equation. It is in two different places. You haven't isolated it. you can't solve it for C while it's still on the left and the right hand side of the equation. So while the right hand side looks the way we want it to, this doesn't count as being solved for C because it's in two different places. So that doesn't work. What you have to do is rewrite the equation so that there's only one C in the equation instead of two. And I can think of two ways to accomplish this. And one way is kind of the hard way to do it, and one way is the easy way. So I'm going to show you the easy way. All right, so we have Q. Let's rewrite the problem. Q equals C minus CST. And this problem's a little bit unfair to give you at this point in the semester because we're going to have to use something that we haven't really learned yet in this particular way, which is we have to factor out the common factor. And we're going to learn about factoring in chapter 4. So this is a little bit ahead of where it should be in the course, maybe. You could argue that. But it is based on a principle that you should already be familiar with, which is the distributive property. Right? So the distributive property is this property here, A times B plus C. Right? So whenever you have a situation that looks like this, you can distribute the A into the parentheses and write it as AB plus AC. That's called the distributive property. Right? We're distributing the A into the parentheses. I think everybody should be familiar with that at this point in your math academic careers. However, what you might not realize is the rule works in both directions. And this is true for any math rule, right? If there's an equal sign in it, it works left to right, it works right to left. And so if I flip this around, it would still be true, right? So flip it around, put the right hand side on the left hand side. We have AB plus AC equals A times B plus C. This would also be true. And so this is still the distributive property, but it's written in the reverse order of how you're used to working with it. And if you think of it this way, right, okay, so now let me change colors. Okay, what's happening is you're taking a thing that is common to both terms, right? A is common to both of these terms, and you're undistributing it. So I like to call this undistributing. You're taking the A away from both of these terms, writing it one time. That's the key, right? You're writing it one time outside parentheses, and then in parentheses you write what you have left over, which is a B from the first term, C from the second term. Right? That's what's left over. That's what goes inside the parentheses there. All right. And so that's what we're going to use here. It's the distributive property in reverse. We're undistributing something that's common to both of these terms. So we have these two terms here. What's common to both of them is the letter C. And so we can undistribute that. We're going to take the letter C away from both of these terms. And just like you see in the distributive property, we're going to write it one time out in front. And then in a set of parentheses, we write what's left over from each of these terms when C is taken away. Right? That's how we get this part right here. Now, for the second term, it's pretty obvious. What's left over is S and T. Right? So we'll have ST left over from the second term. We have a minus sign in front of that. What's left over from the first term? You might say nothing, and that's understandable. It looks like there would be nothing left over, but there's really an invisible 1 here. We just don't see it. It's really 1C, right? So when I take the C away, a 1 would be left behind. So whenever you're using this property, there's always something left behind. And if it looks like everything's being taken away, there's going to be a 1 left behind in its place, right? And so this is what we'll have left over here. And the left-hand side will still be Q. So now we've gone from having C in two different places to having it in just one place. Now we can isolate that C on the right-hand side of the equation. It's being multiplied, sorry, that's supposed to be a multiplication there. It's being multiplied by this parentheses. So how do I get rid of that parentheses? What cancels out a multiplication? Division. I'm going to divide by 1 minus ST on both sides. So whatever's in that parentheses, that's what we divide on both sides of the equation. That cancels it out from the right-hand side. So 1 minus ST's cancel out. We get C by itself equals Q over 1 minus ST. All right. And so that would be solving it for C. Now it's isolated on one side of the equation, right? There's only one C here. There's no C on the left-hand side, so we isolated it on the right-hand side of the equation. So this is how it should look. So as long as you know that trick, it's really not that hard of a problem. It's only 2 steps. You undistribute the variable, and then the parentheses gets divided to the other side of the equation. So be ready for that. You're going to see a couple of those on the homework, and I always put one of these on the test. So be ready for a problem like this on the exam. As long as you're ready for it, it shouldn't give you too much trouble. All right. Now we have a couple more problems I wanted to look at. One of them is, you might call this a word problem. There are a lot of words in this problem. It's a little bit verbose, a little overly wordy. But I don't really think of this as a word problem. We're going to be looking at word problems in the next section. This is really just a plug and chug problem for the most part. It's a formula problem. So all of these words here are given to you to explain what the formula is doing. So an individual's basal metabolic rate, hope I'm saying that right, is the minimum number of calories required to sustain life when the individual is at rest. It can be thought of as the number of calories burned by an individual who sleeps all day. The formula for basal metabolic rate for a man is R equals 64 plus 6.27W plus 12.7H minus 6.6A. Right, so those variables are there. There's multiple variables. I have no idea what they are. That's what the formula is trying to describe. R is telling you what your metabolic rate has to be for this situation. So that's what the first couple of sentences was about. And then what's about to follow is, what do these other variables stand for? R is the calories per day, right? I guess, I don't know if that's the metabolic rate or not, but R is calories per day, W is weight, H is height, and A is age. So we're getting all of these words because they're just letting us know what all the different variables are doing. Part A asks us to do the following. A person weighs 181 pounds. That's the weight, right? And so that's going to be W. Let me pick a different color here so it stands out a little bit better. So this will be W. The person is 5 foot 8 inches tall. That's their height. Let's try that again. Write it down here. And is 32 years old. That's their age. Use the formula for the basal metabolic rate for a man to find the person's basal metabolic rate. Right, so yeah, we want to find the metabolic rate, which means we are looking for R. Right, that's the thing we don't know. And so we have a formula to do that for us. So this is what we call, in mathematics, plug and chug. You plug the numbers in that you're given, do the arithmetic, that's the chug part, and you get your answer. So it's not really a word problem, because to me a word problem is you have to take the words, translate them into math, logically fit out how the math fits together, then solve the equation that you get after you put the equation together. That's really what a word problem is. There's no equation to put together. They give us the equation. It's the formula that's given, and we just have to take the numbers and plug it in. All right? And so let's go ahead and do that. So we'll have R equals, we just have this 64, it's a constant, plus 6.27 times W, which is the weight, which is 181 pounds, plus, now here we're going to have a little bit of a speed bump, 12.7 times H, which is 5 foot 8, which doesn't really fit into a formula because it's a number that's split into two different units. And so if you read this closely, the height has to be in inches. I don't want the 5 foot part. The 8 inches is fine. That's the units I want. 5 feet, I have to convert that into inches. So to convert feet into inches, there are 12 inches in 1 foot. So that means there's 24 inches in 2 feet. There's 36 inches in 3 feet. And so you could work your way up to 5 feet that way, or you could realize the pattern there is you multiply by 12. Right? So 5 feet actually is going to be 60 inches. That's in addition to the 8 inches here. So altogether, the height of this person is 68 inches. So you have the 60 inches plus the 8 inches here. And so that gives me the height, which is 68 inches. All right, and is 32 years old. So minus 6.6A, which is the age, which is 32. All right. And so you get all these numbers, and I don't have a calculator handy. I guess I could use my phone. I'm not used to using my phone as a calculator, so this might take me a second. So we have 64 plus 6.27 times 181 plus 12.7 times 68 inches minus 6.6 times 32. Now this looks like a reasonable answer, so I think I did this right, hopefully. I'm getting R, but you might want to double check me on this. R equals, 1,851 calories. I don't see here where it says how to round the answer, because that's not it. I got 0.27. I'm guessing it's going to say round to the nearest whole number. So I think if you just type in this part, you're going to be fine, because 0.27 rounds down to 1851. So I think that's what we would type in to Math Excel. Somewhere on the homework screen, it should tell you round this answer in this particular way, or it might say, type the exact answer, in which case you want to put in the 0.27. Part B is practicing what we were just learning earlier with the problems of solving a formula for a different variable. It's currently solved for R. Part B wants us to change that and solve it for W. So let me write the formula down here. We have R equals 64 plus 6.27W plus, and I don't want to leave the numbers plugged in. We're going back to the variables, 12.7H minus 6.6A. We want to solve this for W, which means I want to get W by itself, which means all of these terms here with these variables all need to go to the other side of the equation. And so we're just going to move them over there by performing the opposite operation. So positive 64, I'll cancel that out by subtracting 64. Plus 12.7H, I'll subtract 12.7H. To cancel out minusing 6.6A, we will add 6.6A. And all of that's going to happen over here on the left-hand side, which I'm running out of room. So we'll do all the same things on the left-hand side of the equation. So we're going to get R minus 64 minus 12.7H plus 6.6A, and on the right-hand side we'll have 6.27W left over. All right. So all of this stuff, all the things I circled here, got moved to the left-hand side of the equation. And all we're going to have left over here is the 6.27W, which isn't quite solved for W, right? Because we got to get rid of that number. So we'll cancel that number out by dividing by 6.27 on both sides. Now when I go to divide the left-hand side, the entire left-hand side has to get divided by 6.27. And so I make sure the fraction bar reaches all the way across. That's going to cancel the 6.27s out on the right-hand side. And this is what I'm going to get on the left-hand side, which I don't have room to rewrite. So this is going to go away. We'll have W equals this thing right here. And that's what you would want to type into Math Excel. All right, so that's the formula solved for W. So while it looks like a scary problem on the surface, once you read through it and see what you have to do with it, it's not too bad. Plug some numbers in and compute with a calculator, and then solve the formula for a different variable, which isn't, there's a lot of terms, but it's not complicated. There's no undistributing, there's no factoring or anything like that. It's just shove all the stuff to the other side of the equation. All right, so I have one more problem here that maybe you could try first. So if you're watching this video, maybe you could pause it at this moment, try to see if you could solve this formula for H, right? Because probably in my face-to-face class, that's what I'm going to do with this problem, is have my students try it in class instead of me doing this one for them. You do have a fraction to deal with here, so see if you can figure out what to do with that fraction. And then once you've tried to come up with something, and by the way, you can do this at any point during any of the videos that you're watching. Pause before you actually watch me do it and see if you could do it yourself first. You'll learn more that way if you try it first, even if you don't quite get there. You'll learn from that experience. So, even when we make mistakes, right, we learn from those mistakes. So try it yourself first, see what you come up with, then resume watching the video to see if you come up with the same answer. All right, so we are going to solve this for H, right, which is stuck in the parentheses. Now, there's a couple ways you could handle that. You could get rid of the parentheses, because we talked about that in section 1.1, right? You can't solve for X while it's stuck in the parentheses. So get rid of the parentheses by distributing, but it's a fraction. I really don't want to distribute a fraction. That sounds like a mess, and it would be. It's going to get kind of messy if you do it that way. What you could do is get rid of the fraction, right? You're multiplying by 9/2. You could do common denominator. So if you want to get rid of the 2 here, you're dividing by 2. So to cancel out dividing by 2, you multiply by 2. If I do that to the right-hand side, got to do the same thing to the left-hand side. So I'm going to get 2a, and this is a little bit confusing because we have the parentheses here times the 2 times the fraction, And you don't have to distribute the 2 into the parentheses and cancel it out with the fraction. You not only you don't have to do that, you shouldn't do that because it would be wrong. The 2 is only here to get multiplied once. It's not being distributed to both of these things because you're not adding or subtracting. It's not the distributive property. You have 2 things that you're multiplying together. These are being multiplied, and the 2 is being thrown in there, being multiplied with those 2 things. It's not getting distributed to each of them. It's just 3 things being multiplied together at this point. And we can choose the order in which we multiply these things together. So I'm going to multiply the fraction to this number here, this 2, which I can think of as 2 over 1, so that the 2's can cancel each other out. And then it's gone. It doesn't also get multiplied to the parentheses. We just used it up on the fraction, right? And so what we're left with here is the 9 that I'll go ahead and copy down, and the parentheses, which is the h minus 17. I'm sorry, that's supposed to be an h there. All right. So that's what I would do, is get rid of the fraction rather than distributing a fraction into the parentheses. Let's just get rid of the fraction. And like I said, it's a little bit tricky because it looks like you might want to distribute it and multiply it to both of these things, but you don't, because they're being multiplied. The distributive property doesn't apply, right? We saw the distributive property earlier in the video. This is the distributive property. You only distribute the a if the 2 things in the parentheses are being added together. But here we have a 9/2 and we have times the h minus 17. We have 2 things that are being multiplied. So when I multiply a 2 to this, it doesn't get distributed because we are multiplying, not adding, right? What happens in this case is you choose one and multiply it to that one thing. You don't distribute it. You take this 2, you either multiply to this or you multiply to this. You make a choice. Once you make that choice, it's used up. So we're choosing to take the 2 and multiply it to the 9/2. So the 2's can cancel out. And so therefore we chose not to multiply it to the parentheses. All right, so I hope that was clear. By multiplying by 2, you cancel out that denominator of 2. Right? And that's all that happens. All right, now we could go ahead and distribute the 9 if you want to, or you could get rid of the 9 by dividing by the 9. But in keeping with the way we've been doing the previous problems, let's just do it like this. We distribute the 9. We get 2a equals 9h. I don't know why it's not writing there. Okay. It's doing it again. 9h minus, I have to use my calculator again on my cell phone. So let's see, we'll have 9 times 17, which is 153. All right. And then we want to get h by itself. And so to get h by itself, we will add the 153 to the other side. And we get 2a plus 153. Unfortunately, those don't combine together, so we just have to write them side by side, equals 9h. And then we will divide by 9 on both sides to get h by itself. Remember, the fraction bar goes all the way across, divides both of them, so we end up with 2a plus 153, the whole thing divided by 9, equals h. So this is one way the answer could look. Now, I did ask you to pause it and try to work the problem out yourself. And you notice, as I worked through that problem, I had some decisions to make, which means there's multiple paths through this problem. And you might have made some different decisions, which aren't wrong, but just different. You could have gone through the problem in a different way and still got the right answer, but maybe it might come out looking a little bit different. So another way your answer might have looked here is you might have 2/9 a plus, let's see, what would I get here? 1, and then I would have 63, so 17. I think you'd have 17 left over. This would be another way that the answer could look, which would also be correct. And it could also possibly look like this, depending on how you went about it. So maybe you write it like this instead. It's kind of the same thing, but the fraction's written a little bit differently. So any of these would be correct. There's just different ways of writing it. And the way I'm getting from one form to the other is I'm taking the answer I got, taking the 9 that I'm dividing by, and dividing it into both of these separately. And that's how I'm getting these alternative answers to this problem. So any of these answers should be correct. MathXL should count any of them as correct answers. All right, so that is section 1.2, formulas and applications. If you have any questions, if I'm your instructor, please contact me. If I'm not your instructor, then contact your instructor if you had any further questions about any of these problems.